Let's now solve the third Newton's second law problem. This is a vertical problem, and it's a combination problem. So let's take a look at what we first have. We have 3 crates tied together, and we want to know the lowering force. Easiest thing to do is to combine all 3 to start, just like we did with the last problem. So if we combine all 3 crates, let's see what we end up with. 15 kilograms. P. Notice, even though P is a lowering force, it acts up. Think about it. It's a lowering force in a rope. The direction or the tension is up because ropes don't push on things. The weight mg points down, which is 147 newtons. Before we do anything, we need to decide on an axis. If you would like to make sure you make the fewest number of mistakes or the possibility of mistakes, always choose the direction of motion as positive. Since the blocks are moving downward, call positive y downward. Everything now relates to our axis. Notice there's no normal force here because there are not surfaces touching each other. So all we have is one crate with 2 forces. Sum Fy equals MAY. So let's see what we end up with. Make sure everything lines up with our axes. Since we called y down, mg in this case is positive. And we end up with mg minus p equals MAY. 147 newtons minus P equals 15 kilograms times A, or P equals 147 newtons minus 15 kilograms A. We'd be able to get the answer if we knew A. Notice I started with this problem and I didn't try to find A first because I really didn't know that I needed it. I wanted to start with the problem that had what I was looking for, which was the tension P. So how can we get A? Well, we know one other technique, and those are motion problems. The link between sum F equals MA and motion is A, or acceleration. A is in both types of problems. So we are going to solve a motion problem. Even though this is vertical, it's not a free fall problem. The crate is not freely falling because there's more than one force. Gravity is not the only thing. But we set it up the same way, and we cannot change our axes. Look, we have a start. We have an end. We have to use the same axis. 0 meters per second because you were told it started from rest. And we know it moves 6.52 meters in 3.71 seconds. So this is a motion problem. You were told V0 equals 0. Delta Y, 6.52 meters. The time was given as 3.71 seconds. And we are looking for A. Please remember A is not 9.80 meters per second squared here. A is only that value vertically when an object is in free fall, and this object is obviously not in free fall. And the other terms are V and V bar, which we don't care about. So now we can solve. We need an equation. Delta Y is V0t plus 1/2 AT squared. This works out well since V0 is 0, and we can solve this for A. 2 delta Y over T squared. And when we shove in all the numbers that we have, we end up with 0.947 meters per second squared. It's not a very large acceleration, but it is non-zero. And now we can substitute that all the way back up here for A. And when we substitute that in for A, we end up with P equal 133 newtons. Notice P is not the net force on the object. P is simply the lowering force. P is not the net force, it is the lowering force. Also notice it must be smaller than the weight so the object can accelerate downward.